2024 A-Level Combined Mathematics Paper 1 Part A question number 2. This is the graph and modulus question. The question says, sketch the graphs of y equals modulus of x minus 3 plus 1 and the graph of y equals 5 minus modulus of x in the same diagram. It then says, hence, find the area of the rectangular region enclosed by these graphs. So basically, when you draw these two graphs, there is going to be a rectangular region enclosed by them that we will see when we draw the graphs. And then given that, we need to find the area on the inside of this rectangular region. Now, to start off with this question, the first thing we're going to do is to draw some coordinate axes like this that we can then use in order to draw the graphs of y equals modulus of x minus 3 plus 1 and y equals 5 minus modulus of x in the same diagram. Now, to start off with the first one, we can see we have y equals modulus of x minus 3 plus 1. Considering this graph, there are multiple different ways we could draw it. One is to just select random x values and substitute them in, but there is of course a better way. The best strategy for this kind of thing is to find first the symmetrical point. Now, given any kind of graph with a single modulus inside of it, you are definitely going to have some kind of symmetrical point. The reason for this is that with a modulus, the modulus is going to be positive always, and at a certain point, it is going to be 0. Now, to the right side of that point and the left side of that point, since everything on the inside is going to anyway be positive, if you have a linear function on the inside, that linear function is going to be forced positive to both sides, meaning that the graph should be symmetrical about the point where the inside of the modulus is equal to 0. Now, considering this graph, we can see we have x minus 3 on the inside. This is going to be equal to 0 when x is equal to 3. And therefore, we can say the symmetrical axis is going to be at the point when x is equal to 3. Now, on this graph, if I draw that, we can see if we put this as x equals 1, put this as x equals 2, put this as x equals 3, and put this as x equals 0, we can see our graph, whatever it is going to be symmetrical about this point. Now, considering that if we start drawing the graph, at the point when x is equal to 3, we can see the inside of the modulus is going to be equal to 0 since we have 3 minus 3 modulus, which is going to be 0's modulus, which is 0, and then plus 1. So therefore, at the point when x is equal to 3, which is the symmetrical point, y is going to be equal to 1. So we can write here, if we put this as 1, the point 3, 1 is going to be on our graph. Now, considering some other points, if we take, for example, x equals 0, when substitute x equals 0 into here, we're going to get 0 minus 3 plus 1, and here 0 minus 3 is going to become minus 3, and the modulus of minus 3 is going to become plus 3, and therefore we have plus 3 plus 1, which is going to be plus 4, and therefore at x equals 0, the value is going to be plus 4. So if we draw that in, we have 1 here, 2 here, 3 here, and 4 here. So therefore the point 0, 4 is on our graph. Now moving on, if we consider some other points, we can see 4 values of x greater than x equals 3. The inside here is going to be positive, and therefore the modulus doesn't do anything. So therefore what I'm going to have is y equals x minus 3 plus 1, which is going to be y equals x minus 2. Now therefore we can say that our graph is going to be just a straight graph that goes up like this, and it is going to go through the point 2, 0, because if you substitute 2, x equals 2 into y equals x minus 2, you're going to get 0. So therefore, for the right side, for the side that is on the right side of x equals 3, our graph is going to be a graph that goes through the point of 2 here, 2, 0. However, it's of course not going to be there since this part of the graph doesn't actually exist, because 4 values of x less than 3, the graph is going in a different direction. So therefore, it only goes until that point at x equals 3, and then it turns around. Now for the other side, we can see, since we have this point at 0, 4, we can just draw the graph from that point onward like this, through that line at 0, 4, or rather through the point at 0, 4. Now therefore, this right here is going to be the graph of y equals modulus of x minus 3 plus 1. Now we could, if we want, just extend this a little bit, show that this line is in fact going through the point 2, 0, and maybe on this side we could show that the line is going through the point 4, 0 if we wanted, but this is not really necessary, but I'll just mark it anyway. So now we can see we have this part of the graph. What we need now is to mark y equals 5 minus modulus of x. Now for this one is quite easy, because for the inside of the modulus to be equal to 0, x must be equal to 0. And therefore at x equals 0, this thing is going to be symmetrical. So considering x equals 0, we can see y is going to be equal to 5 minus 0, and therefore the point 0, 5 is on the graph. So if I mark that point right here, this is 5, we're going to have the point 0, 5, which is going to be on our graph. Now considering the other points, we can see we have y equals 5 minus modulus of x. For x is greater than 0, it's going to be positive, so therefore it's going to be y minus 5x, and therefore this thing is going to go through the point 5 comma 0, since at that point x is going to be equal to 5, and therefore we're going to have 5 minus 5, meaning that y is going to be equal to 0. So therefore we can say the right side of this graph is going to go down like this. Now importantly, it's important for you to note that this line right here is parallel to this line right here, since both of these lines have a gradient of -1. The first graph has a gradient of -1 due to the fact that it's going to be equal to 3 minus x plus 1 over 4 minus x, and the second graph has a gradient of -1 since it's going to be equal to 5 minus x. Now considering that for the left side of x equals 0, we're going to have y equals 5 minus, and the inside, since the inside is negative, we're going to have negative x to make it positive again, and therefore we're going to have y equals 5 minus negative x, which is going to be again plus x, and therefore the graph is going to be y equals 5 plus x. Now due to this, the graph is going to look like this, and again it's important to note, when the graph is drawn like this, the gradient of this line that we're drawing here is the same exact thing as the gradient of this line here. In fact, we can see that if we simply mark out each of these individual line segments equations. Now I'm going to do that real quick, I'm not going to explain it too much. We can get that from finding the signs of the things inside of the moduluses for the right side and left sides of the symmetrical axes. Now for the first one, when we have these values, which is the values of x greater than 3, this is going to be positive, and therefore we are going to have y equals x minus 3 plus 2 plus 1, which is going to be y equals x minus 2. This graph here is going to be y equals x plus 5. This graph is going to be the negative version of that, which is going to be y equals minus x plus 5. And this graph here is going to be what happens when the inside here becomes negative, which is going to be 3 minus x plus 1 or 4 minus x. So therefore we're going to have y equals minus x plus 4. Now with that, we can see these two graphs have created a rectangular region right here. This region is rectangle because these two lines here are parallel and these two lines here are parallel. Now considering this thing, what we want to do is to find the area on the inside of it. In order to do this, I'm going to label a bunch of points. I'm going to call the point at the very bottom here the point A. I'm going to call this point the point B. We'll call this point here C. And we'll call this point here D. And we'll also call this intersection point right here the point E. Now considering these points, what we want to do is to find the length DC or the length AB, and then we want to find the length of DA or CB, and then we need to multiply those two in order to get the final area. Now considering these graphs, since these graphs all have gradients of either 1 or -1, we know that the angles involved are all 45 degrees. There's a 45 degree angle here, there's a 45 degree angle here, and there's a 45 degree angle here, and so on and so forth. Now due to this, we can say the angle here is 45 degrees, and if we draw vertical here, the angle here is 45 degrees. If we draw horizontal here, the angle here is 45 degrees, and that is actually enough for us to find all of the values that we want. Now if I just mark that really quick, if I just draw a little sketch here, actually I need to move this A to somewhere else. I'll move the A down here so that I can have space to mark the angle. I'm going to mark with a horizontal at this point right here the angle here as being equal to pi by 4, and similarly I'm going to mark the angle on the inside here as being equal to pi by 4. Now given this, I can find the different lengths that I want. I can find DC easily. Considering DC is going to be, if we take a look here, since E is at the point 0, 4 and C is at the point 0, 5, we can see CE is a distance of 1, and since C is a distance of 1, we can see if DC has this angle here of pi by 4, then this length right here is CE sine pi by 4, and due to that, DC is going to be equal to 1 times the sine of pi by 4, and since the sine of pi by 4 is 1 over root 2, DC is going to be equal to 1 over root 2. Now considering that if we consider some other lengths, we could find the length BC or the length DA using this angle right here. I'm actually going to use this length right here. Now considering this length, we can see the length DE here can be found again from this triangle here. Since this length is going to be equal to 1 and this is the cosine of the angle, we can say that DE, which is the length from the point D to the point E, is going to be 1 cosine pi by 4. So therefore DE is 1 times cosine of pi by 4, which is going to be again equal to 1 over root 2, since cosine of pi by 4 is also equal to 1 over root 2. Now if we put those two aside for now, we can see in order to find the total length DA, we also need to find the length of EA. Now considering EA, we can see since A is at the level of y equals 1 and E is at the level of y equals 4, we can say the distance between this level and this level is 4 minus 1, which is 3. So therefore the vertical height here is 3. Now considering the angles, we can see EA is the hypotenuse of this triangle, where the opposite angle to pi by 4 is equal to 3. Now due to this, we can say EA sine pi by 4 is equal to 3. So we can say EA sine pi by 4 is equal to 3, and converting this, we can see if we multiply both sides, we're going to get, if we multiply here, we're going to get EA equals 3 root 2. And therefore, the EA length is equal to 3 root 2 and the DE length is equal to 1 over root 2. Now considering this, if we just take all of these and add them together, what we want are the lengths of DC and DA, because if we have those two, then we can find the area of the rectangle ABCD. Now considering this, DA, which is the length that we want, is equal to DE plus EA, which is equal to 1 over root 2 plus 3 root 2, which if you take under a common denominator, we can see, taking this thing under common denominator, we need to multiply by root 2, which is going to be 3 times root 2 times root 2, which is going to be 3 times 2, which is 6, plus 1 is 7. So therefore we have 7 divided by root 2 as the total length of the side DA. Now considering this, we can say therefore the area of the rectangle, and we can say ABCD is equal to the product of DA and DC, since we can see here DA is this side length and DC is this side length. So therefore we can finally say, therefore the area of rectangle ABCD is equal to DA times DC, which is going to be equal to 7 divided by root 2 times, and DC is 1 divided by root 2. So therefore our answer is 7 divided by root 2 times 1 divided by root 2, which we can see we have 7 on top and we have root 2 times root 2, which is going to be 2 on the bottom. So therefore our answer is 7 over 2. And therefore the final answer for this question is 7 over 2. Now finally, if we consider the marks awarded for this question, in this question, when you draw the two graphs, for the first graph, if you draw all of the points correctly, which are all the intersection points, which is this point right here, the point at x equals 3, y equals 1, which is the point A here, and if you draw this line and this line correctly, with this line's graph being represented by y equals x minus 2, and this line's graph being represented by minus x plus 4, you're going to get 5 marks for that. Now similarly, for the second part, for y equals 5 minus modulus of x, for drawing this intersection point right here, this line correctly, this intersection point, and also marking the upward graph as y equals x plus 5 and the downward graph as y equals minus x plus 5, you're going to get a total of 5 marks for that part of the graph. So you get 5 marks for this curve and 5 marks for this curve. Now after this, for your solving, when you find the length DC as being equal to 1 times sine pi by 4 is equal to 1 over root 2, you get 5 marks for that. After this, when you find the other length, which is DA, by finding DE and EA separately and then adding together to get 7 over root 2, you get 5 marks. And then when you write your final answer by multiplying and getting 7 over 2, you get another 5 marks. Now here, you could either directly write 7 over 2, or you could be a little bit more precise and say, since we don't have actual units here, since we only have, coordinate plane and there are no actual units, you could also say 7 over 2 square units. Since we don't actually know what the units are, we just have numbers in the x direction and the y direction. Now in some mark schemes they have expected 7 over 2, and in some mark schemes they have expected 7 over 2 square units, but they haven't given any specific mark for the square units bit. So all you really need is the final answer, which is 7 over 2. And with that, we have covered the full 25 marks, and that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.